In this video, we're going to be looking at piecewise functions. We're going to introduce the concept and do some basic operations with them. So let's begin with the definition. So a piecewise function is a function that is defined by two or more equations over a specified domain. So essentially what we're doing is we're saying for these particular x values, use this rule, and for another set of x values, we use a different rule. Now, the general format for a piecewise function is this. So we start by naming our function. So we'll start with just a basic f of x. Then what we do is we use a curly bracket. So the curly bracket is used to kind of like put our two together. So next we have the rule. So let's change colors here. So next we have the rule, followed by the domain. And same thing is true when we're doing multiple. So we would have another rule followed by a different domain. Now these domains are not going to be overlapping, meaning there cannot be x values in this value and that one in both of those domains. That would make it not a function. So these are very specific domains that do not overlap, meaning we're going to have to use less than or equal to's, less than, greater than signs, showing that these are not equal. So let me show you what I'm talking about. So here's an example of a piecewise function. So you see here it follows the format. I've got a big curly bracket, I've got my name, and then I have my rules. So here's my first rule, here's the domain. Second rule, here's the domain. So I'm going to graph these to kind of illustrate what these look like. So for the top one here, I'm going to do this in red. Here's what this is saying. This is saying when x is bigger or equal to 2, we're going to use this rule. So all these values, x is greater than or equal to 2, we're going to use this rule. And for this one, when x is less than 2, we use that rule. So I would plug it into this equation. So I'm going to go ahead and graph this one. So the first x I can plug in here is 2. So I'm going to do -2 plus 5 and get the value of 3. So this tells me the point 2, 3 is a part of my graph. So I'm going to do that. 2, 1, 2. We're going to make it a solid dot. Now it's a solid dot because this is an equal to, meaning that 2 is a part of this particular rule. Next, I'm going to finish graphing this. So when x is greater than 2, so that would be to the right of this point, I'm going to graph this line. So I know this is a line because it's mx plus b, and I have a slope here of -1. So I'm going to go down 1 over 1, down 1 over 1, and so on. And then I'm going to connect it as best I can, like so. So there is my first part of the graph. Now let's do the second part. So for the second part, I'm going to use blue. So what I'm saying is when x is less than 2, we're going to use this rule. Now what I'm going to do to start this graph is I'm actually going to start by plugging in 2. Now you could be saying, well, if I plug in 2, but that's not part of my domain. Very true, but here's what we're going to do. So the point 2, 1 is going to be our border. That's where we're going to stop because we want to include every number up until 2, and we want to stop at 2. So what I'm going to do here at the point 2, 1 is I'm going to put an open circle. Now what that does is it lets me go up really, really close to 2. That means I could plug in 1.99. And I'm covered. So I'm going to plug in this as my border. I'm going to put an open circle because it's not part of the domain. And then I'm going to graph this line. I have a slope of 2 here, so that means I'm going to go up 2 over 1, or in this case, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Let's see if I can connect those. So then I connect this line. Oop. You get the idea. So I'm defining it over 2 different parts. Now let's evaluate. So for this first one, I'm going to find f of 3. So to evaluate f of 3, what I have to do is first determine what part or which rule do I follow. So f of 3 is going to go in the top one. Here's why, because 3 is greater than 2. So since it's greater than 2, I'm going to plug it into this rule. So -3 plus 5, and I get a value of 2. Which is the 0.32. I already knew that from my graph, 32. Next, I'm going to do the same thing for -4. So when I look at -4, it is not bigger than 2, but it is less than 2. So I'm going to plug it into this rule. So it'll be 2 times -4 minus 3. That gives you a value of -11. So that's how we do a basic graph is we use these as kind of our borders, and then we follow other graphing rules to work it out. Now, this word discontinuity, so you have this question here, are there any discontinuities? Well, the answer to that question is yes, but let me explain what a discontinuity is. So a graph is continuous or discontinuous. Those are some things we're going to be looking at. So a continuous function is a function that doesn't have any breaks or jumps. Now there are way more specific definitions when you get into calculus, but we're going to keep it pretty straightforward for right now. So the short way you can determine whether something is continuous is you ask yourself the question, can you draw the entire function without picking up your pencil? So if I'm drawing a basic curve or a sine curve, something like that, well, hopefully it's a little straighter, and I see that there are no jumps, I could do this whole thing with just not picking up my pencil. That is a continuous function. Now, discontinuous, it's the opposite. It means it has breaks or jumps. So like in the last graph, we had a solid dot with an arrow, we had an open dot with an arrow, and I could clearly see a jump. I can't draw this picture without picking up my pencil. That's not allowed. So this would be something called discontinuous, meaning it has a hole or a jump. So let's do another one and look at the discontinuities. So for this one, we've got 4 when x is less than or equal to -4, and 6 when x is greater than -4. Now you could be thinking these are very weird rules, but let me explain how this works. So I'm going to start by plugging in -4. Well, if I plug in quote unquote -4, I'm going to get a y value of 4. So that means my first point here is -4, 4. So 1, 2, 3, 4, 1, 2, 3, 4, -4, 4, and I'm going to put a solid dot because I have an equal to here, meaning that -4 is part of my domain. Now this says that this is the rule for when x is less than -4. So that means I'm going to go to the left here, and it is a horizontal line. Every x value is going to give me a y value of 4. Now for the next one here, we've got x is greater than -4. So it means x is bigger than -4, gives me a value of 6. So I'm going to have the point -4, 6 is going to have an open circle because -4 is not part of the domain. However, we want to get really, really close to this x value. So next, we're going to go to the right. We're going to show all of these x values give us a y value of 6. So by looking at this, are there any discontinuities? The answer to that question is yes. And what x value is it at? It is at the x value of -4. So let's do one more example, a little more complicated, just to kind of wrap up. So for this one, I've got a lot going on here. I've got 3 different parts. I have 3 specific domains. So let's break it down. So let's start with the first one. So the first one here, I have x is less than -3. So for all the x values smaller than -3, I'm going to use this rule. So that's how I'm going to start. Is I'm going to plug in -3. -3 minus 4 gives me -7. So that's going to be -3, 1, 2, 3, 4, 5, 6, 7. And I'm going to have an open circle because -3 is not part of the domain. Next, I'm going to continue to graph this. So I see I have a slope of 1. So that means I'm going to go down 1 over 1. That gives me that positive slope. And there is the first part of my graph. So for any value smaller than -3, I'm going to plug it into this value. The next one's a little trickier. Here I've got a quadratic. I've got x squared. So I'm going to start here at -3 and I'm going to end at 1. That's what this is saying. So I'm going to start by plugging in -3, and that gives me a value of 9. -3 squared is 9. So that would be -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is going to be a solid dot because I have that equal to right here. So that's included. Next, I'm going to plug in 1. So 1 squared also gives me 1. So it looks like this. Now remember, a quadratic makes a parabola, so I need the vertex. Now, in this case, the vertex is really easy to find. It is just 0, 0. If you want to review finding that, you can go check out my other videos. So then I'm going to go ahead and connect these. It's not exactly accurate. I didn't plot all the points in between, but I'm pretty close. Didn't have to. Okay, so that's where I'm showing you. Now, both of these are solid dots because -3 is included in the domain because that equal to, 1 is included because that equal to. Let's do the last part. So for the last part here, I've got x is greater than 1. So I'm going to plug in 1 to start. Well, when I plug in 1 to x, I get 1. So I'm going to have an open circle here at the point 1, 1. Now, if you notice here, they overlap. That's okay. You can have that. They can overlap. Well, I have an open and a closed circle. So technically, they don't overlap, but you get the idea. So next, I plot the rest. So it's a slope of 1 because it's just 1x. So I go up 1 over 1 all the way to the top. And let's connect it. So it looks like this. So there's my piecewise function. Now, before I get into discontinuities, I want to do a little evaluating just to practice. So let's say I do f of, let's say, 2. So if I'm doing f of 2, I have to figure out what domain does it fall under. Well, 2 is not less than -3. It's not between -3 and 1. So it has to go in this last one. So f of 2, plug it in, gives me a value of 2. What if I said, we'll change the black to not give it away. How about f of, let's say, -4. So if I look at -4, it has to go in the top one because -4 is less than -3. So I'm going to do -4 minus 4 is -8. So let's wrap this up. Are there any discontinuities? The answer to that question is yes. Now you could be thinking, well, there are 2 discontinuities. No, they're not. There's actually only one. If you look at my graph, this is not a discontinuity because the graphs overlap, even though one's open, one's closed, and then I continue. I could have drawn this whole section without picking up my pencil. So this is not a discontinuity. This giant jump, however, is a discontinuity. So we would say yes at x equals -3. So that concludes our basic introduction to piecewise functions. We're going to do more with this. There's a lot you can do with these piecewise functions and apply them in different situations.